The objective of this demonstration is to initialize an identity matrix. So I write here program identity. I write end program identity. Implicit none. And we have to declare all of our variables by ourselves. So I say identity of size 5, 5. And I require integers ij. So let's initialize it. I write here do n varies from 1 up to 5. And I write here do 5 varies from 1 up to 5. Of course, the identity matrix is a square matrix. It is valid for a square matrix. So for this case, I say if I is equal to j, then ij is equal to 1, and else I of j should be equal to 0. So this is for diagonal entry. This is for diagonal entry, and this is to set the off diagonal entries. And if, and here we require the end of inner loop, a slightly inconvenient way to write in strictly Fortran 77 standard. Continue, right? And then the printing stuff, and we learned how to print it. So I write in the model structure 1 to 5, and I write here print statement, print ij, where j varies from 1 up to 5. This is the implied do loop, and I write here do, right? So this is the default. This is the printing in on terminal. So matrix is going to be printed accordingly. I write here a title, print of identity matrix. So in this program, I have initialized the identity matrix with the name EYE. Interestingly, the convention to store the identity matrix, or to call the default identity matrix, is EYE. In Python, in MATLAB, the name EYE is for identity matrix. Okay, let's save the program in our working directory. Okay. Notepad++ have identified our directory. Identity.for. And to run it, I write cmd, and I will get to the directory from this terminal. First G directory, and then within G directory, This is our working directory. Then compilation command, compiler name, then program name, and the execution file name. So we expect a 5x5 identity matrix to be printed by this program. But first, let it be compiled correctly. Hard time for me. Okay. Okay. There is 1 comma extra. Okay, so it has been compiled. So I think everybody is ready to see the success. A 5x5 matrix is going to be printed in front of you with at diagonals 1, 1, 1, and at off diagonal we have zeros. So the check was made on the basis of index of row and index of column. So that is the strategy to set the values for off diagonal entries and for the diagonal entries. And now let me make another step. Now instead of printing it here, I'm going to print it in a file, right? In a separate file. It is not very difficult. It is not very strange thing. I will slightly change the print statement. Since I'm going to print on a file, therefore everything will remain the same. But I have to first define the file. Right? The file must have file name, its status. Is it available or not? Right? Or if we want to overwrite on it. So some of the attributes I'm going to give here. So first, write here open. So a file should be open in case you want to write on it. So first thing, I write here a unit name. Unit name means like roll number for you. So you are identified in university with your registration number. So that is the registration number, right? Now I write the name of the file. So I write identity.out, right? You can give any name over here. Then the status, this file is has not been created, right? So the program has to communicate with the computer memory to create that file. So I write here the status as the new file, right? Of course, this is logical. So a file has been identified or registered in this program, and we identify it with its unit number 15. File name has been associated with that, and its status new. So now I will print the output on this file with similar commands. So instead of print, I require a specification of file. I use a statement write. Write statement contains two positions, right? One for file unit number and one for format. In print statement, there was only one asterisk. So you can only provide the format for printing. So here one is for the file specification and one for the format. So the file unit I specified 15, and let's work with the asterisk, default printing. And again, here, this is the print of identity matrix, the same thing that I provided earlier. And instead of this statement, I slightly modify it with the write statement, right? On unit 15 with the same type, right? Everything remains the same. You have to just create the file identification, and then everywhere you can call the file with its unit number, right? We have suggested a name for it, and that is identity.out. You can provide here any kind of extension, .in, .out, .dat, .txt. All files are possible, right? So let me first show you that this file is not present in the directory, so that there are no lurkings, nothing hidden. So bin directory. So is there any file with the name identity.out? Identity.exe is there. Identity.for is there, but there is no other file identity.out, right? Right. So my demonstration is clear and fair. And now the time to see printing on file, right? Compilation. Successful. Compilation is successful. There is nothing out of the bounds of Fortran, right? Program has been executed, but nothing has been printed over here. There is nothing. But if we look for the folder, now if I press I, so there is identity application file, there is identity.for file, and there is one identity.out file, right? This is the file we are interested in. Let's open it. And behold, print of identity matrix, a 5x5 matrix has been printed on a separate file. With large matrices, we do reading and writing of data from files. We store the values in a file, and then we read those values from that separate file, say 1000 by 1000 matrix. So it is very inconvenient if you start writing the values on the command window. So we first develop the file and then read those values as such. The only thing that you require is the creating the identity of the file, right? Its properties, and then you can use it. You can call it in read statement and write statement by its unit number.